right, a goal for today is I will be able to determine if a relationship is linear or nonlinear, and we're going to be able to do that whether we have a graph, equation, or a t-table. Okay, so section 3.3. Okay, so our title, linear versus nonlinear relationships. Okay, first of all, the easiest one to talk about whether something is linear or nonlinear has to do graphically. Okay, so for instance, here we have a graph of a non-linear relationship. Now you can see it's not a straight line. So that's the first thing that you can see. And that's how we really tell graphically whether something's linear or not. So the first thing, we have a curved or break in them. Okay, so all nonlinear graphs will have either a curve like this one does, or it will have a break. Okay, and that means they're nonlinear. Also, remember we've been talking about slope? Well, if you look at this graph, actually, there are infinite amount of slopes in this graph. So if I took and there's a little dot here, so I could figure out the slope just at that one location. But then you can see the graph changes a tiny bit, so I could actually find a slope there. And so what happens is wherever you pick, you're going to have infinite number of slopes, and they will be different. So that's how we tell graphically whether something's nonlinear. The opposite is true, obviously, if we're talking about a linear graph. So all linear relationships are a straight line. So they are resulted in a line. And when I say a line, I'm meaning a straight line. Okay, and you think, well, what other kind of line are there? Well, there are other lines as well, because we use the word line interchangeably, especially if we're talking about art. And things such as outline your drawing with a line, and that might mean going non-linear in a sense. So when we talk in math, linear, we're talking about a straight line. So line, straight line mean the same thing. Now, the other thing that we know is a linear relationship have have slopes. Okay, so linear relationships have a slope. There's one slope. Okay, so if I pick 2 points, I'm going to get the same slope whether I choose those two or whether I choose a different set of points. Okay, so that's graphically how we tell whether something's linear or nonlinear. The next way that we can tell is through equations. Now, right now I have, let's see, we have 5 graphs here. I have 5 equations, and now we're going to talk about these equations, about their graphs. I'm going to put the graphs so we can see and then compare which ones are linear, because we know graphically how to tell, and see if we can come up with some kind of pattern when we're talking about the equations. So what I've done is I brought up the graphing calculator just so that we very quickly can see what they look like. I could easily draw them, but just so that you have an understanding. So you've seen the graphing calculator, and so the first graph we're going to enter is 3x plus 2. And when I go to graph it, it looks like it's pretty much a straight line to me, so we're going to just draw roughly what that looks like. And so I'm going to bring up a line, and it appears that it goes something like this. Okay, so that's what that graph looks like. And let's go and try the next one. And so we're going to go back in here, and it says that it's x squared plus 2. So we have another graph. And this time I think I'm going to have to draw it freehand. And it looked something like this. Something like a U. And the next one, now you can see we have a square root of x. So we actually can enter that right into the calculator. Then plus our 2. And if you look really closely at that, it's really difficult to see because I know that the graphing calculator is a bit small, but you can see that it does have a curve to it. It's not a straight line. So let's draw that one. And actually that in grade 11, you actually study those types of graphs. So it's kind of like this on its side. And the next graph, when we go to do it, it's going to be 1 divided by x. Oh, now that worked pretty fast. So take another closer look at it. So I'm going to go back to here. I'm going to graph it. And you can see that it has 2 parts to it. Okay, and again, that's another graph that you will study when you are in grade 11. Oops, I'm going to try to redo that again. So there was this part of it that goes on, and this graph was kind of funny because it has 2 parts to it. And finally, we have 5 minus x for a graph. So up comes our graphing calculator again. And if we do 5 minus x and graph it, okay, so it looks like it's a straight line as well. So now when we look at these lines, first of all, we can see that this was linear, and that's great. We can see that, and it is hiding behind here. I know it is. So it's linear. This one obviously is nonlinear. This one is nonlinear. This one was nonlinear, and this one was linear. So when we're looking at equations, you're not going to have these graphs. So let's see if we can find some kind of pattern between the equations that are linear. So that's this first one and this last one. What do they have that is different than the nonlinear graphs? And it's actually quite interesting that you can just look at a graph and tell. What we're interested in is looking at our variables, in this case y and x. If you look for the x, for instance, this is to the power of 1, and the y is to a power of 1. So that's really important because if I look over to the other linear one, it was to the power of 1 and power of 1. Now, let's go look at the other ones. Do you think that might make a difference? Well, here I have an x squared. So it appears that my x is to the power of 2, which it is, and that gave me something that was nonlinear. Now this one here isn't to x squared, but you can see that it's in a square root. So actually the power that it is to, and you don't realize this because you don't have the experience with radicals yet, is it is x really to the power of 1/2. So because you don't know that, if they've done something strange to the x, they put it underneath a symbol, then it's going to be nonlinear. Then if we look at this last one, think back to exponents. If I want to change this and flip so that the x is on the top instead of on the bottom, that would make it x to the -1. Okay, so it appears if they do a squared or a -1, or if the x is underneath some kind of weird symbol, it results in a nonlinear relationship. So actually we have a little rule to help us with equations, and this is how it goes. It is an equation is linear when both the x and y have an exponent of 1 written in the numerator. Okay, numerator. Okay, because this one here, 1 over x, does have to the exponent of 1, but it's in the denominator. All right, so there's that one. So let's actually go do some examples to see if we can actually come up just by looking at the equations this time. Okay, so when I look at the first one, and we're going to examine it with the magic pen first of all, I can see my y's to the power of 1, and well, I have 0 times x. Well, it's to the power of 1. Now, normally I wouldn't see any of this here at all. Okay, now put it there on purpose. So we have y to the power of 1 and really not an x. So therefore, it's going to be linear. So we're going to use just an L for linear. And let's look at the next one, number 2. If we examine it also with our magic pen, x is to the power of 1 and y is to the power of 1. So I'm actually going to put that with something that will permanently stay there. So this one also is linear. If we look at number 3, we have y squared and we have x to the power of 1. So if I go back up to our statement, an equation is linear when both the x and y have an exponent of 1. So here it's nonlinear because y has a squared. Okay, now we have y to the power of 1 and we have this x underneath the square root sign. So we know that that creates an issue. We saw that graph up higher. So this also is nonlinear. If we go to number 5, we have a squared on our y, squared on our x. So this is nonlinear. And here again, I'm only looking at the variables. I'm not looking at the constant numbers. X is to the power of 1, y is to the power of 1, so it is linear. And finally here, I only have x's, and it's to the power of 1, so that means it's linear. So it is possible, such as in example 1 and 7, that they could have written number 1 as y equals 2, and you wouldn't see that 0x. It's the same here. We don't see the plus 0y, but you can see that what we have is an exponent of 1, so that's why it's linear. Okay, now moving on. So far we should be able to tell from a graph and from an equation whether something is linear or nonlinear. The next part takes a little bit more work for us. Okay, and I'm going to stop the video and start fresh so that we're not going to run out of time. Okay, so we're going to look at the third way to tell if something's linear or nonlinear.